Hello all, good afternoon, good morning. Welcome to the Semtech BlueRiver ASIC webinar. My name is Mike Taylor and I'm with corporate marketing here at Semtech. So without further delay, let's get started. The BlueRiver ASIC series will help grow the SDVoE ecosystem by enabling more functionality in a number of key applications. These include large venue displays, medical AV, esports, and more. With major benefits including system cost and power reduction and transceiver functionality, designers can create the next generation of smarter and more efficient Pro AV solutions using the ASIC. Getting into the agenda, in today's webinar we'll be providing a bit of background onto the BlueRiver platform, introduce the new ASIC series, as well as discuss several of its applications and integration before getting to your questions during the Q&A. We also want to take this time to let you know that we have a great new video up on the BlueRiver Tech page of the Semtech website, which illustrates just how the technology works along with its advantages, so we recommend you check that out after the webinar. I'm going to now hand it over to Gareth Haywood, Semtech's Video Products Market Manager. Gareth, if you want to take it away and tell a bit about yourself before getting started. Thanks.
Thanks, Mike. Good day all and welcome. I'm Gareth Haywood. I'm a Senior Product Manager for Pro AV products at Semtech, and I've been primarily responsible for the launch of the ASIC, which we're going to talk about in detail today. But without further ado, let's look at what is BlueRiver technology. So BlueRiver is Semtech's award-winning platform that has contributed significantly to the growth of the AV over IP market. It's also the core technology behind the software-defined video over Ethernet, or SDVoE. And it's recognized as the only true replacement for legacy matrix switching applications. So what does BlueRiver enable? Well, it allows you to transport video up to 4K resolution with sub-millisecond latency. It provides pristine artifact-free image quality with visually lossless fidelity. We can transfer audio signals, control signals, many of the signals required for typical Pro AV applications. And all this is done using standard 10 gigabit Ethernet networking technology and using a common applications programming interface, or API. Just drilling in to look at some of the typical applications that we support. There's a number of markets and verticals that are benefiting from SDVoE technology, which includes things like live events, esports, command and control, high-end residential AV, medical AV, corporate and education applications, military, hospitality, and retail. And the key here with BlueRiver is the low latency. That sub-millisecond latency and high quality are essential to verticals such as medical and esports, where you want very little latency and you want the fidelity to remain very, very high. Now, what do we mean when we say the matrix transformed? So let's take a look at this picture. On the left here, we have the traditional approach using matrix switching technology. And on the right, we have a typical SDVoE type setup. What you'll see is that the dedicated AV switcher and the KVM switch is replaced with a standard 10 gig Ethernet switch. So this truly is a standard 10 gig switch. And the difference here is now that all this functionality can be replaced with software. So things like dedicated multi-viewer and video wall processors, this is costly hardware that has dedicated functionality, is actually baked into the BlueRiver solution. So essentially on the right here, this SDVoE system will pretty much look the same for any kind of install. And advanced features such as video wall shown at the top right and multi-viewer below, these are all enabled through software. So it's a very powerful system that can be augmented or upgraded just through software. Let's look at this typical system again and look at some of the key kind of applications that we support. At the basic level, of course, we support matrix switching. This is basically taking your sources that are shown on the left of the diagram there and sending them to the display directly and being able to switch sources in real time. And we offer both two different modes of operation there. We have what's called Genlock mode, and this is where the display is locked to the source resolution. So for example, if your source is 1080p, your display will be showing a 1080p image. However, some display technologies require that the picture is the same format regardless. So what you can do is you can choose fast switch mode. And in this case, the receiver always outputs the same resolution to the display. So the display remains locked to that resolution. And whenever you switch a source, regardless of its resolution, it will always remain synchronized and output the same resolution. So this is a very powerful tool, even for simple matrix switching applications. The next advanced feature would be video wall, where I think we all pretty much know what a video wall looks like. I'm showing one at the top right there. In this case, we do provide a number of unique features that mean that video walls remain synchronized. So each of those receivers, once it receives a command to say you are in video wall mode, it knows which position it is within the video wall, and it ensures that motion is synchronized across that video wall. And then you avoid any kind of tearing or judder effects. We also provide bezel correction. This is important for displays that have quite a large bezel, for example. You can see in this picture that you need that surfer to look like he's behind the bezel as the motion goes across. And we provide the scaling feature to be able to do that. Again, another advanced feature shown at the bottom here in the diagram would be multi-viewer. The nice feature about doing things over IP is it's all subscription based. And the receiver that's driving that multi-viewer can subscribe to as many sources up to the bandwidth limit of the 10 gigabit Ethernet network. And then inside that receiver, there's a full video compositing engine that allows you to do any kind of custom layout. This is perfect for doing applications such as quad splits or picture-in-picture. So you can see you just need one receiver connected into the network, and you can subscribe to multiple sources to provide very powerful multi-view applications. And finally, shown just off to the right there, is keyboard video mouse or KVM applications. We fully support USB. This allows you to do things like remote operator applications, where you've got your PC locked away in a machine room, and the operator is sitting at a terminal that just includes the keyboard, the monitor, and the mouse. And we fully support integration with third-party KVM software. And we'll talk about this in quite a bit of detail later. As I've already mentioned, the SDVoE API really is the heart of any SDVoE system. And it's common across all BlueRiver products, both old and new. It's got a dedicated command set where all the typical Pro AV requirements have commands that are already there to allow you to do things like scaling, to allow you to do audio down mixing, frame rate conversion, etc. And the nice thing about this API is it abstracts the user experience from the hardware platform itself. So think of this like a smartphone. Your smartphone is a very powerful piece of hardware technology. However, what makes it extremely useful is the apps that you run on that iPhone or Android phone. So think of the application programming interface as a way to access all those different applications with a common set of hardware for Pro AV. The other nice thing about being a common API across all BlueRiver enabled products is it enables interoperability. And right now, there's over 200 existing SDVoE products on the market today that are all interoperable with each other. You can check out some of those products at the SDVoE Alliance product catalog webpage. It's worth taking a look. There's a lot of good products out there. Okay, so let's now look at the ASIC. What we've done with the ASIC, we've taken what we call our existing FPGA-based BlueRiver technology into a highly integrated, low power and small form factor ASIC, which significantly reduces your overall implementation costs. The power, if you compare it to a typical FPGA-based system, is reduced to about a third, and the cost to almost a half, depending on the feature set you require. We do support both copper and fiber network connectivity. This allows you to target existing copper-based infrastructure, which is very prevalent today, but also take advantage of fiber and future-proof any investments for next-generation video resolutions that require higher bandwidth that can only be supported by a fiber interface. We have 3 devices in the BlueRiver product line. We have the entry-level AVP1000, which is designed primarily for just high-performance switching and distribution of AV content. This works all the way up to 4K 60. There's no limitation on format support. It supports all the same set of peripherals as the other devices. The only thing it doesn't have is the AV processing capability, and it's also limited to copper connectivity only. To get the AV processing plus fiber support, you can use the AVP2000. This has the broadcast quality scaling engine. It has the video compositing engine. It includes all the video wall processing and bezel correction needed to do video wall applications. And as I said, supports fiber connectivity via SFP plus modules. What's new with the ASIC platform that's different from what's available today is the AVP2000T that provides true transceiver functionality. This lets you send and receive HDMI via a single chip. And this is really taking advantage of the bidirectional nature of 10 gigabit networking. So with a single chip, you can both transmit, i.e. HDMI in up to 4K 60, and receive an output over HDMI up to 4K 60. So very powerful indeed. And we'll look at the transceiver and some of its key applications it enables in later slides. Let's drill down a little bit and look at some of the key features and specifications of the ASIC. So all device variants, it's a single device. It's configurable as a transmitter or a receiver. So this really simplifies your design. You can build one box and you can configure it as a transmitter or a receiver. You can even do that live in an install. So depending on how you design your hardware, if you've got both an HDMI in and out on the board, at install, you can choose whether it's going to be a transmitter or receiver, and even change that dynamically if you require, to give you a very versatile system. However, what's new to the market with the transceiver functionality that I mentioned is this support for bidirectional HDMI. This allows you now to build a box that can be a transmitter or a receiver or a true transceiver. So you have three options there, basically. All these devices support the full 4K 60 444 format, 10-bit 422, HDR, and all HDMI 2.0 audio formats. The other thing to note is that all these devices support a complete set of peripheral interfaces. That includes multi-channel digital I2S audio, both input and output on a single device. That's very useful, for example, for doing things like audio return channels on HDMI. You need both in and out to be able to do true HDMI with audio return. We have a fully integrated USB HID interface now. We've got RS-232, infrared, GPIOs, and consumer electronic control. All the typical interfaces you need for large-scale Pro AV installations. On top of that, every chip has a 1 gig Ethernet network port. This is designed for not only 1 gig networking, but you can also piggyback third-party IP data streams into the SDVoE 10 gig system. An example of this would be Icron Extreme USB 2.0, which can come in through the 1 gig and then traverse over the 10 gig SDVoE network, Dante Audio, even compressed AV. So you could have both your full bandwidth, high quality SDVoE feed, but maybe a lower resolution, highly compressed proxy that you may want to use, for example, to do thumbnail previews or for recording onto PCs. All device variants are fully pin compatible using a 576 BGA package at about 25 millimeters by 25 millimeters. And the real key advantage is the power. With an FPGA-based system, typically an FPGA that you would use to do 10 gig networking is going to run in somewhere in the 7 watt range, maybe even higher, depending on the number of features you have running. With our ASIC, with all features running, full-blown transceiver operation, typical power is around 2.6 watts. So there's a significant power saving there. Let's look at some different application scenarios. And what we're trying to show here is that you have a choice depending on what your system requirements are. It's not just a case of buying one device to do all. If you really want to keep your system priced down and you don't need any of the more advanced features, for example, you're just replacing a matrix switch to do extension and switching, then the transmitter and the receiver can be AVP 1000 based. And in this case, your software complexity is quite low because all you're doing is basically enabling sources to switch to sinks. And your volume potential here is high because this is the most common use case for doing matrix style switching. If you want more advanced features such as scaling or fast switching, as I mentioned earlier, and video wall mode, you still only need an AVP 1000 in your transmitter, so you can still use a very low cost based transmitter. On the receiver side, by making that an AVP 2000 based receiver, you can do all the AV processing, scaling, switching, video wall modes. Of course, the system price is a little higher, the software complexity goes up a little bit. And then finally, the most advanced feature is multi-view. That's that ability to subscribe to multiple video sources to create a multi-view on a single display. In this case, we need the AVP 2000 in the transmitter and the receiver. So obviously your system price is increased, and that brings some software complexity to be able to do the setup of all the multi-view applications. And you can mix and match these applications all in a single install. So some of your transmitters might be 1000 based, some might be 2000 based. It really depends on your capabilities that you need on an endpoint basis. And the key one here is that all AVP devices are fully interoperable with existing BlueRiver NT1000 and NT2000 based products. So you can augment existing installs with ASIC based products without changing any of the software or even disrupting the operation of that install. Now let's look at what the transceiver functionality brings to the table. So with this true bidirectional HDMI connectivity, we can enable a whole new class of products. You can take advantage of this transceiver functionality combined by having the lower power to do things such as wall plates. And what I'm showing here is two different rooms and the ability to share resources between those rooms. In this example, you've got a PlayStation in room 1 and an Xbox in room 2. However, room 1 wants to be able to access that Xbox, and without carrying it into the other room, you simply plug it into the wall plate. You take the controller to the other room and plug it into the USB on the wall plate, and you can now happily use the Xbox in room 1, and similarly, room 2 can use the PlayStation. And these wall plates can be nice and compact because of the low power operation that comes with the ASIC and enable very low cost, low power type resource sharing applications. Another application that utilizes this bidirectional capability is for things like media servers or video wall servers used in signage. What the AVP 2000T allows you to do is have a single 10 gig SDVoE network connection into your media server, but be able to simultaneously record and play out content. This is a really nice feature for video signage applications. So for example, you may be streaming out some signage onto your displays, but at the same time on the network, you're also recording some updated signage that's coming in through that AVP2000T and being recorded. And then you can very easily switch to play out the new signage that you've just received using the same device. So it really saves you some space and cost in those kind of media server applications. The other key feature that we've added with the ASIC is the integrated USB HID interface. And I'm going to look at these applications in quite a bit of detail, because these enable a lot of keyboard, video, and mouse, or KVM applications, which are very powerful applications for things like command and control. We support direct connection and switching of any HID class device through any AVP-enabled endpoint. And typically, this would be a mouse, keyboard, touchscreen, or even a joystick. This really enables low-cost KVM applications with simple integration into any kind of third-party KVM software. And I'll talk about that in a lot of detail in a slide coming up. With fully networked KVM switches, this allows applications where you can have, for example, a single operator controlling multiple computers or hosts just with one set of USB peripherals. So the first application I'm going to show is a simple point-to-point switching application. This is where you've got, you can see in the diagram, you have 4 different users. Each of them is at a workstation, and these are fairly generic workstations. They're just a keyboard, a mouse, and a display. And then you have your remote hosts. For example, they could be locked away in some control room. And here, whenever the user that's read there logs into this workstation, it automatically connects him to his remote PC in the machine room. And you can do that for each of the users, and you can change that depending on where the user sits on what day, for example. The next kind of application that you could do very, very simply is things like collaboration. Here, what we've done is we still have multiple users, but we only have one PC in this case. And this could be used, for example, in a classroom for doing kind of like interactive quizzes, and allowing students to all access the same PC, but they all have their own unique view on their screens. This next one I'm showing is what we call power user, or dynamic switching of USB. And if you look in the diagram here, you have a single user, and he's actually sat at a workstation that has one keyboard and mouse, but it has 4 displays. And if you imagine he slides that mouse so the cursor goes from screen 1 to screen 2, it will dynamically switch to PC 2 that's remote. And again, if he continues to slide across to screen 3, it switches to PC 3, 4, etc. So we're going to look at this in a little more detail because we're wondering how this is actually achieved using networking technology. If you look in this diagram, you'll see at the bottom there in the middle, this server that's sat on the network. This is the server that's typically running the SDVoE API and all the software control to be able to set up and control the system. Also running on that same server, or it could be another server, you have some KVM software. Typically, we call this a KVM server. And what happens is that when you connect that USB keyboard and mouse to the receive box that's at the bottom right there, the traffic that's generated out of that box is then intercepted by this USB KVM server, and it determines what to do with that. So for example, it will know that when the mouse is on screen 1, it should be connected to remote PC 1. And as the mouse hits the hard right, for example, of workstation 1, it will then know that the mouse should switch to screen 2 and allow control of remote PC number 2, etc. So this is a really powerful tool to let you do dynamic switching across multiple hosts where the mouse seamlessly moves from screen to screen. This access to the USB network by third-party KVM software is very powerful, and this allows KVM server specialists to develop SDVoE-based KVM applications very quickly. Another key feature of the ASIC is what we call endpoint integration. The ASIC enables full integration into end equipment, allowing you to put native SDVoE connectivity on both AV sources and displays. And this is enabled by the low power and low cost of the ASIC. This enables a whole new class of SDVoE products and really helps to expand what we call the SDVoE ecosystem. You can see in this diagram at the top, in the typical application that we've already shown, where you have, for example, a media server and a 4K projector. Right now, the connectivity goes via some appliance or device outside of that box that converts the HDMI signals into 10 gig SDVoE to go over the 10 gig network, and you do the same on the other side. With endpoint integration, basically the chip is inside the source or the display. And that can be done using, for example, PCIe capture cards for PCs and media servers, as I've already mentioned, but also things like native SDVoE connectivity using an option card on a projector. And this really does reduce the cost and complexity, not only of the end products, but the system itself. And by being fully integrated, this provides better interoperability between manufacturers. For example, there's no issues with using different appliances from other manufacturers that may not have the full level of features that you do once it's integrated in the endpoint. It's also full backwards compatible with existing SDVoE product offerings. So for example, if you do upgrade a system to a new projector that has native SDVoE connectivity, it will plug into the network and work just as it did before with the external appliance. So in summary, we've seen that the BlueRiver AVP chipset really is enabling a new generation of lower cost and lower power products. And this will really drive the growth and expansion of the SDVoE ecosystem. Hardware designers can grow existing product lines, knowing that the ASIC-based solutions are fully interoperable with existing solutions. For software designers and developers, you can continue to develop new and exciting applications, knowing that both generations of endpoints are all controlled by that common API. You can take current installations and expand them with ASIC-based devices without any disruption to existing control software or any existing installed endpoints. And this really is a big deal. This saves a lot on installation costs and downtime. And the market's really hungry now for AVB over IP solutions that provide that true matrix switching performance. And SDVoE is the only standards-based approach capable of meeting matrix switch application requirements. So for everybody who's on this call, there's a lot of opportunities out there for this market that's expanding very quickly. And early adopters will realize quite a significant market share, and the race is on, folks. So with that, I'm going to open up to questions. But first, I just want to point out that if you do want to have any kind of follow-up and get more information, not just on BlueRiver and the new ASIC, but SDVoE as well, you can contact me or any of my business development partners that are shown here.
All right, thanks so much, Gareth. We've received quite a few Q&As so far throughout the presentation, and just everyone else on the call. If you do have any questions, now would be the time, so feel free to submit those. So just getting right into it, we have a couple here from Stefan Billet. First one, what compression format and ratio do you use for 4K 60 or 1080p 60 over 10G? And is the compression ratio user settable?
That's a really good question. So the BlueRiver philosophy is only to use compression where needed and when it's needed. As a result, basically the compression is determined by the source signal format. So for example, in your question there, 1080p wouldn't be compressed at all because it fits no problem over 10G. The only time compression kicks in is when we exceed the bandwidth of that 10 gigabit network. The compression is fixed at a ratio of about 1.4 to 1.
Okay, so then a follow-up question from the same person. Does HDMI to IP support all intro frame, including dynamic metadata for dynamic HDR?
Absolutely.
For example, HDR 10 plus and Dolby Vision.
Yeah, absolutely. So that's a key capability of BlueRiver. We do ensure that what comes in is what goes out. So in terms of any kind of HDR format, we do ensure that all the info frame information is preserved.
Okay, great. Next question, is there a plan to add support for SMPTE 2110?
Oh, very good question. Well, firstly, I just want to clarify that SDVoE is designed for Pro AV applications from the ground up, and it's what we call a full stack solution. If you look at SMPTE 2110, it's really just part of the solution for AV over IP. It only actually covers up to layer 4 of the OSI stack. If you look at doing things like registration, discovery, and control, all the things that we've already baked into the SDVoE API, they're actually defined elsewhere, and they're not defined in the standards body itself. And when you look at those various APIs, they're very much focused towards broadcast workflows. There's little to no definition of flows that would be required for Pro AV, such as things like infrared, USB, RS-232. HDCP is a big one. And also, typically, 2110 is focused on supporting broadcast video formats, whereas we are focused on basically any panel format or image format under the sun. I actually suggest reading, there's a good Semtech blog where I do a full analysis of this comparison to give you some idea of why SDVoE, we believe, is the right choice for Pro AV, and SMPTE 2110 remains firmly a broadcast-based technology.
Thanks, Gareth. That's great. And yeah, we'd like to take the time to say we have a ton of great resources on the Semtech website as well. So we definitely recommend you check out the Semtech blog. There's a lot of really good Blue River content from Gareth and other members of the Blue River team on there. Next question, what is the max power the user should design for?
So that's actually quite a detailed question, and that's something that you would have to probably consult the data sheet to get an exact answer. I can say that the typical power consumption is around 2.6 watts. In a lot of cases, it's going to be lower where you're not, for example, doing A/B processing. And it's also going to be heavily dependent on whether you use 10 gig or 10 gig copper rather, or optical. So you're going to get some different power performance there. So my suggestion is really to, if you wish to dig deeper, then sign up with us, and we can provide the data sheet to give you all that gory detail around power requirements.
Great. This next question is actually about 10 gig, since you mentioned that. Dario Pagano asks, is the 10 gigabit Ethernet PHY integrated directly into the ASIC?
No, in terms of the 10 gig copper PHY, we actually rely on a third-party external PHY for that. And the reason we do that is we want to be fully IEEE compliant. We find that if you compare to, say, HD-Base-T, for example, which is a proprietary PHY, their crosstalk and alien noise rejection performance is extremely poor, because it doesn't include all that advanced DSP processing that many 10 gig PHY manufacturers have spent many, many years and man hours perfecting. So we want to take advantage of that. Also, we want to be agnostic to the physical connectivity. So that's why, for a lot of applications in the future, we see moving towards fiber. We allow you to connect either through a fiber SFP plus module or a standard IEEE compliant 10 gig PHY.
Okay, next question here. Danny Pierini asks, you just mentioned you are standards-based. Which standards?
The standard is based on a lot of the 10 gig networking standards. So there's nothing that's proprietary up to about layer 4. So a lot of the standards we're compliant to would be IEEE based, including a lot of the network protocols. And then obviously with the SDVoE Alliance, a lot of members are contributing to the development of Blue River technology through the Alliance, and it's standardized through that path.
All right, thank you. Next question from Stephen Barlow. What prevents the AVP 1000 from supporting 10 gigabit optical ports?
It's simply the device configuration. It boots up, can only support copper connectivity. So it needs obviously to see certain handshaking between a 10 gig copper PHY to work appropriately. And it obviously, nothing will happen if you connect up an optical based solution.
All right, the next question, will native Ethernet enabled endpoints using Blue River ASIC be supported using power over Ethernet?
Yes, the PoE, again, because we rely on standard IEEE compliant 10 gig PHYs, we're able to, it's your choice. You can use that with PoE or PoE plus type solution. So, for example, we have reference designs which show how you would use PoE. And obviously, depending on what your endpoint is, the designer of that endpoint would have to determine what the power requirements are needed over PoE. But yeah, that's all fully supported, but it's not specifically part of the ASIC. It's more a system level design.
All right, great. We mentioned dynamic HDR. Does the ASIC support HDMI 2.1?
Not yet. No, HDMI 2.1 is currently not supported, and we're looking at obviously at future generations of ASICs which will fully support not only 2.1 but up to 8K resolution.
Awesome. Another question from Dario Pagano. Does the ASIC handle HDCP, or is this handled using a separate HDMI transceiver?
Yes, so it is using a separate HDMI transceiver, but anything that is HDCP protected, typically it's the audio and video feeds from an HDMI input, is still encrypted throughout the SDVoE network. So endpoints will only decode the signal if the HDCP is compatible between both source and display. So we still fully provide the HDCP handshaking and maintain the encryption over the 10 gig SDVoE network.
Okay, and we got a follow-up question on HDCP. What are our HDCP device limits? Are we limited to 32?
Really, that's a system level design. There's no, I can't think of any specific limit unless there is some limit to the HDMI transceiver that's used itself. But typically in a system, customers are not going to that sort of number of levels of handshaking. But obviously, if you get into something like a video all application where you have a lot of panels, that you could reach the limits, for example, of the source HDMI receiver or transmitter, I should say. But no limit within the ASIC and the technology itself.
Okay, no limit within the technology itself. All right. Thanks for clearing that up. New question here from Kelly Franz. They ask, can I decode SDVoE or BlueRiver source on a PC?
Yes, there are a number of SDVoE vendors now offering capture cards. They also provide an SDK that allows you to record, transcode, stream, and more. And I think I mentioned it earlier, but it's worth checking out the SDVoE product catalog on the SDVoE webpage if you want to see some solutions that are already available.
Okay, question here about our AVX product. They ask, is the AVX product compatible?
That's a great question. Yes. So basically, when a BlueRiver-enabled device is connected directly to an AVX powered device, and for those of you who are unaware, AVX is a point-to-point only chipset that we offer for just pure extension. What happens when a BlueRiver device sees an AVX device, it will automatically switch into point-to-point mode. And if you want more details on this, you can, again, check our website. And I highly recommend maybe even booking a session with one of our business development contacts shown here to discuss that in detail, because there's some very neat applications you can do with both a mix of AVP or BlueRiver devices and AVX extender devices.
We have a great new AVX FAQ page on the BlueRiver technology page as well, for any of your questions about AVX there. Question here, how much DDR is needed around the ASIC?
So the DDR is only required when you're using the AV processor. Off the top of my head, I can't remember what the exact requirements are, but that's fully defined in our reference design for you to take a look at. Again, I highly recommend, looking to sign up with one of the gentlemen that's listed here below in your region, and they can provide you all that detailed technical support. But typically, we have two devices hooked up, two DDR devices, and the DDR3, and these are just required, as I said, when you're using the AV processor or you're doing fast switching where you need a frame buffer.
Okay, new question here is a two-parter. They ask, are there any specific features developed for healthcare applications? And is it only the 2000T that provides an audio back channel? So I guess two separate questions, rather.
Yeah, so as I mentioned near the top of the presentation, we are very much focused on medical applications, primarily because in medical, they require the very low latency and they need the high fidelity image quality. So, those are two key features that are specific for healthcare. There's many other things in there, the ability to support a multi-view with a touch screen is another key one. So, for example, a surgeon or a nurse or anyone in an OR can quickly select different views. They could select, the view from an MRI, a previous MRI scan. They could look at patient records. It's really all at the system level. And again, as I said earlier, enabled through a lot of software that you can come up with specific healthcare applications. So it's really down to the healthcare equipment providers to come up with these applications that run on the SDVoE platform. As far as the second question goes, the audio is bidirectional on all devices. So it's not just specific to the 2000T.
Is there any kind of FEC built into the Ethernet 10G?
So we have some level of protection for lost packets, for example, but we try to avoid the overhead of FEC. The reason being is obviously we want to really max out the performance without any kind of compression. If you build FEC, there's two issues with FEC. It can lead to increased latency, and it can also lead to higher overhead, packet overhead, which means that we will reduce the bandwidth of that link. And the potential downside to that is you may only be able to support certain image formats with FEC, and maybe you'll lose some of the other peripheral feeds or streams such as USB and 1 gig or audio because there's not enough room left within the link. So we don't use that. 10 gig Ethernet is extremely robust, and especially where you're using fiber, it's extremely immune to noisy EMI environments. And we find that most people that are building systems where they need that level of performance and there can be zero downtime or loss of packets, they're building systems based on very high quality 10 gig switches and using optical fiber connectivity.
All right, thank you very much, Gareth. So thank you all very much for joining this afternoon, this morning, and have a good rest of your day. Bye-bye.
Thank you, everyone. Bye-bye.